Today we are talking about the factors which affects the rate of chemical reaction. We are continuing the chemical reaction and what factors affects the rate of chemical reaction. I have taken these 6 major factors which affects the rate of chemical reaction. Now I want to talk about these factors one by one, how they affects the rate of chemical reaction. Let's talk about first temperature, or sometimes called heat also. Now what can we say? The first one, temperature, or heat also somehow may be written. Now when reactants are heated, reactants means the substance, elements or compounds which takes part in the chemical reaction are called reactants. When reactants are heated, their molecule or atom vibrates more rapidly, due to which the rate of collision of their molecule or atom increases. Just for example, these are, let's say, the atoms of the reactant, or maybe this is the molecule contains more than one atoms. When they react with each other, I mean to say when they are heated, then their molecule or atom begin to move very fast. This is a random vibration. Heat increases the random vibration. The vibration of the molecule becomes very, very fast. And due to fast vibration, what rate of collision means, within 1 second, if they were colliding with each other just 2 or 3 times, then they begin to collide with each other 20 or 30 times or more than that. The rate of collision increases. That increases the rate of breaking up and reunion of their molecule. They will break up very faster and reunite with each other faster, and chemical reaction takes place. Okay, we can take example of this. Just for example, when mercuric oxide is when heated, this is heat sign, then it decomposes into mercury and oxygen gas. We can write balance equation also, 2 and 2. Here if we write 2, then it is balanced. This way, this breaking up of mercuric oxide is possible because of heat that increases the temperature. This is the example of the factor heat or temperature which affects the rate of chemical reaction, which brings the chemical reaction very faster. Okay, now next is calcium carbonate. Also we can take, when calcium carbonate is heated at very high temperature, then it decomposes into calcium oxide and carbon dioxide gas. This reaction is balanced reaction. This is one of the method of preparation of carbon dioxide gas in industrial scale. In this case also, this reaction is brought because of the heat or high temperature. When heated at very high temperature, it breaks down because of the increased vibration, rate of vibration, number of collision increases within their molecules, and it breaks down into calcium oxide and carbon dioxide. This is another example. This is about the temperature. One of the factors which affects the rate of reaction is temperature. How it increases the rate of reaction, I told you this example. Okay, now next let's talk about second one, surface area. Surface area. Now how surface area affects the rate of chemical reaction? Rate of chemical reaction increases with the increase of surface area of the reactants, because more number of molecules of the reactant comes in contact with other when their surface area is increased. Just for example, let's say we have a solid substance, then this is the size. When it is broken down into 2 parts, then what happens? When it is broken down into 2 parts, then 2 new surface area produce, this one and this one, 2 new surface area. And if it is further broken down, then what happens? We have 4 pieces Look at this. Now these are the new surface area. This is new, this is new. These are the new surface area. It means more number of molecules comes in contact with other to which they are these molecules are reacting. Let's say this is a beaker or vessel where some liquid is taken and liquid has to react with this solid substance. Then in previous, if it was like this, then less number of molecules of its surface comes in contact with this liquid, but when it is broken down, then more surface area exposed to this liquid and more number of molecule comes in contact with this liquid, and the reaction between this liquid and this solid becomes faster. This can be taken as example, just for example, zinc pieces when powdered. Look at this. If we take a test tube and a piece of zinc is dropped into it into dilute hydrochloric acid, then by the reaction, how they react with each other, zinc when reacts with hydrochloric acid, then what they form, zinc displaces hydrogen, then zinc chloride forms and hydrogen gas becomes free. That's why diatomic, hydrogen 2 chlorine 2 balance. Okay, this reaction, if a piece of zinc is dropped into dilute hydrochloric acid in a test tube, then we can see the bubbles of hydrogen gas which comes in this reaction. But if instead of that piece of zinc, if we add powdered zinc here, then the bubble becomes very vigorous. At very fast rate, the hydrogen gas bubbles produces because the rate of reaction is increased because of the increased surface area. We can take this example as when surface area increases, then rate of reaction increases. This also affects the rate of reaction. Now let's talk about another point, light. How light affects the rate of reaction. There are many reactions which occurs due to light. Just for example, when light falls on light sensitive substance, then its atom or molecule activates and chemical reaction occurs. Just for example, if we take silver bromide, AgBr, this is light sensitive compound, and when light falls on it, then it decomposes into silver and what? Bromine. Bromine is diatomic. That's why we have to write Br2. If you remember or if you forget, look at this: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. These are diatomic elements. Whenever they are free, whenever they become free, they always appears in diatomic state, and this form in this form they takes part in the reaction or produces after the reaction. But in case of other all other except few other exception, magnesium, calcium, iron, these all are monoatomic. Other takes part in the chemical reaction like silver also in monoatomic state, but these are always diatomic when they become free. That's why I wrote this Br2. Okay, bromine 2, if we take here 2, balanced, silver 2. Okay, this is one of the example of what this reaction takes place because of the light. They say that's why light is a factor which affects the rate of chemical reaction. If light is not falling on the silver bromide compound, then it will break down into these two. There are other reaction also, but this is one of the best example. Let's talk about another one, fourth point. What is written here? Catalyst. No, this catalyst, I took one class for catalyst in previous class. That's why now we are not repeating this. What is catalyst? There are two types of catalyst: positive catalyst, negative catalyst, and what is the function of positive catalyst, negative catalyst. This is already done in another class. I am not talking about this now. Now let's talk about electricity. Electricity is another factor which affects the rate of chemical reaction. Actually, how it affects the rate of chemical reaction? When electricity is passed into an electrolyte, it helps to move the ion to oppositely charged electrodes when they react. It will be better to understand with the help of this diagram. Let's say this is an electrolyte. Let's say this is water and a little amount of acid is added in it, and there are two metallic plates immersed in it, and if these two metallic plates are connected to the source of electricity cell, then whatever, this positive terminal, this is negative terminal, the metallic plate which is connected to positive terminal this is anode, and this is cathode. Now these are anode and cathode. Anode is positively charged electrode, but cathode is negatively charged electrode. Because of the supply of electricity, what happens now? The ionized hydrogen ion and hydroxyl ion, ionized water produces hydrogen ion and hydroxyl ion. When water ionizes, then it produces hydrogen ion and hydroxyl ion. Now positively charged ion move towards this negatively charged plate which is connected to negative terminal of cell, this cathode. Positively charged ion hydrogen move to cathode, and hydrogen gas evolves from this place because of gaining electrons. But hydroxyl ion move towards anode, and it donates electron to anode, and oxygen gas comes from anode. This reaction, this is the ionic reaction. We are not writing this all example, we don't have to give example. We are talking about one of the factor of chemical reaction is electricity. Now what we have to say, when electricity is passed into an electrolyte, it helps to move the ions to oppositely charged electrodes. This is hydrogen positively charged move to negatively charged electrode, hydroxide negatively charged move to positively charged electrode. Thus electricity helps to increase the rate of chemical reaction. Because of this reaction, hydrogen gas evolves from this cathode and oxygen gas evolves from anode. This can be written as this water, we can say here electricity, or it will be better to write electrolyte, and this water produces hydrogen and oxygen gas. Because of this ionization, finally this was oxygen here 1, here 2, that's why it is better to have here 2, this balanced chemical equation. This way we can describe about the electricity, one of the factor electricity. Now next let's talk about the last one. This is done. Now pressure. Pressure is one of the factors which affects the rate of chemical reaction. Okay, pressure. Now what is the reason? Pressure brings the molecule of reactants very close to each other. Just for example, if molecules are a little away from each other, then when it is pressurized, then they comes in contact with each other. The molecule or atoms, whatever we have, they comes very close to each other, so they combine to form compound. This way actually pressure brings the molecules of the reactant very close to each other, so they combine to form compound. Thus pressure facilitates chemical reaction. Just for example, when nitrogen reacts with hydrogen, this reaction is not possible in normal condition. It requires very high amount of pressure, more than 20 atmosphere pressure. Not only this much, it requires temperature also, high temperature. If generally 500 degrees Celsius temperature is needed, but it requires not only pressure and temperature, it requires catalyst also. Iron is used as catalyst and promoter is used as molybdenum. After all these conditions, nitrogen combines with hydrogen to form ammonia. Look at this. Hydrogen 3, here 2. That's why if we take here 2, 3 2 just 6, 3 2 just 6, balanced nitrogen to nitrogen 2. We are talking only about the pressure. This reaction takes place at high pressure, which brings the atoms and molecules very close to each other, and they combine with each other to form ammonia. And beside pressure, there is another factor also, but we are highlighting this pressure. This way, this reaction takes place. Thus, today's focus was what? The factors which affects the rate of chemical reaction. They are temperature, surface area, light, catalyst, electricity, and pressure. I told you about first, second, third, and this fourth and fifth, but this one I told you in previous class. From previous class you can enjoy this. Okay, this much for today.